This is the Amp Hour Podcast. Recorded January 13th, 2015. Episode 232 with Bob Davidson and Dave Vandenbout. Presbytes pushing Portfoliios. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
I'm Dave Vandenbout of Excess Corporation.
I'm Bob Davidson with Ambient Sensors.
And this is another, I just renamed it probably a couple hours before the show, but we're calling this impedance matching because we've had one show in the past where Greg Charvat and Mike Osman came back on, and that was critical success. We thought, why not throw some more guests back together? And Dave and Bob seem like a perfect match. We're going to have a good and possibly cantankerous old time here, and some laughs and talking about the industry and electronics. So welcome back, guys.
Thanks.
Thank you.
We may not be a critical success, but we'll certainly be critical.
Yeah, that's right.
So what's been new? I mean, Bob, you were mentioning before the show you've got some consulting work. Dave, you've still got the FPGA boards and everything like that. How's everything been going?
Why don't you go ahead, Bob?
Okay. Well, yeah, I've been doing consulting work to keep my, product development for other companies to keep my lights on and pay the rent, but I'm also starting to develop some products because I realized that the only way you can really scale if you're just doing consulting type work is either work longer hours or charge more, and there's limits to both of those.
That's right.
But there's some interesting little side projects that I've been developing, a lot of them for my own work, but then figuring that other people might be interested in it. And so, I'm doing some work with Bluetooth low energy, and I just built today a new board that's going to let me create a long-range iBeacon. This is for outdoor applications that has a solar input, but also a battery and a battery management system to allow it to run 24/7, but be powered over time from the sun.
Is that the one that you posted a picture of on Twitter that you said something about, always doing a paper layout or something beforehand or something?
Yeah. I
didn't see this, so I need some prompting here.
Well, it's supposed to fit in a box, and the box is an odd shape, and I laid it all out from the top, and then but I really wanted to have the solar cells on the bottom, so the board's supposed to flip over, but the symmetry of the box doesn't allow that. And I could have checked that because I know better, but I got in a hurry. And but the board's still going to be. I'm just building a couple of prototype boards now, and it'll still be useful for checking out the circuit, and then I'll deal with the shape of it. But I also got burned by this solar cell manufacturer because they had this. I won't say who it is, but they had a spec sheet out that said that the solar cells could be run through a surface mount reflow process. Yeah. So I put it through my I have a little reflow oven, and it melted the solar cells. So then I read a little deeper into their spec sheet, and they said, "Oh, you're supposed to use this silver paste and
just use some kryptonium and
and you bake it at 160 degrees, and apparently 220 was more than it, or 230 was more than it could handle.
Yeah, I bought some little power connectors once from China because they were cheap, and I hand soldered them onto the board, but then I put the boards in the toaster oven to dry them off after I washed them down. And the toaster oven set at like 200 degrees Fahrenheit. And when I took them out, all those little connectors were all just warped and slumped down. It's like they were made out of chocolate.
It happens to everybody, no matter how experienced you get. I think just that's how you learn.
Yeah, the hard way.
But do you?
Well, I learned this. That's not to say that the next time something else won't.
That's right. Small permutations still cause different results, huh?
Yeah.
There's an infinite number of things to go wrong, so
that's right.
You can never get rid of all of them.
Yeah, that's why I get excited when something works, because...
Yeah, I've always said that anything more complicated than a wire is probably going to take 2 tries to make it work.
Well, one of my clients is a software guy, and actually he should know better, but he was wondering why you couldn't just get this stuff perfect from the start. And he was making an analogy to, they build skyscrapers and they don't like build multiple versions of it before they get it right. Of course, that's not exactly true, but
yeah, I read a novel once about building a skyscraper in New York, and it was just one thing after another, and all the little jimmies and shims that they had to put into it, and highly machined little connectors and stuff to get all the beams to meet together in the right way for these, and people, they had these really nice machined spheres with places where these rods screwed into them, and they were using to put together this very beautiful canopy that went over the top of the skyscraper, and the spheres were so beautiful that people in the contracting office kept stealing them and using them for desk ornaments and things like that.
That's awesome. Yeah, I've always wanted to sit in on that meeting because I guess we kind of have that in the electronics industry, but like architects are basically like weird artists, right? They're like artists, but like I want to sit in the meeting where they get just like tongue lashed by the structural engineers and be like, what are you doing here, man? This can't work. Like, have you ever done a load beam before? I mean, like, how is this possibly going to be held up? It's just like taking art projects and then trying to make them stand up over time has got to be the most hilarious and terrifying meeting ever.
It would have been great to sit in on that meeting with Geary when he designed those buildings up at MIT that looked like they had been put through the oven and just they just warped and melted.
I have a story about that actually, because they paid at Case Western, where I went to school. They built it while I was there. It was a Geary building. It was by Peter B. Lewis, by the Progressive insurance guy. Well, they designed it and it was great, but then what ended up happening is the design constraint they didn't put in there, which we're seeing a lot of right now, is, well, when you have a huge metal shiny slidey roof, sometimes the snow slides off of it and knocks students on their ass. So they ended up having to put guardrails around certain parts of the building, because if you walk there, you would literally get flattened by snow sliding off and knocking you over.
Avalanche hazard.
We had
awesome.
At my undergraduate school at North Carolina State, they have a round building called Harrelson Hall, which they're tearing down this year, but it was designed back in the 60s, and it was just a round building, and had a big spiral ramp that went up the core of it that you would go to classes, to get to classes. But all the classrooms had to be shaped like pie wedges, and there was not a right angle in the entire building, which it just drives you crazy with putting desks in the professors' offices and putting in bookcases and anything else. And all the blackboards had to be curved because they were being put on the walls, which were curved. It was just a complete mess. It was, supposedly beautiful, but it was, impractical to do it that way.
They needed flexible electronics.
Yeah. Well, yeah. And that's kind of the way around it, right? I mean, like you could probably shove. I'm looking at your picture now on Twitter now, Bob. You could probably shove a bunch of flexible electronics into this enclosure, but you got to basically pay for the privilege of doing as much.
Oh yeah, no, that's why hardware, is hard to do, and the thing is that once it gets this fully developed, I didn't expect the first board to work, and you just learn from each one and then improve it. Like I have a bunch of ideas already after building this board, even though I'm fairly happy with it, that I want to add to it. One of the things I want to do is that I didn't do, but it'd be fairly easy to do, is pull out the I2C to some pins so that I can add external sensors and so forth to it.
Oh, that's a good idea.
Yeah, and that's the interesting part about doing the design is how much those ideas come to you when you're doing the design, whereas so often you hear about people that say, well, I just want to be the architecture guy. I want to design the architecture and, then have somebody go off and do the nitty gritty details. But so much of the improvements and the new ideas that you get are made while you're actually just forcing the board into the shape that it has to be.
That's
and one. This is close to that. And, why can't I do this? And
That's one of the things, and that's kind of maybe how Chris first got alerted to Dave and I was recently re-alerted to us because we were talking about.
Right. I've been totally ignoring you guys since
bad
then.
Pennies, man.
Talking about that.
Walking past you on the street, just like covering my eyes. Oh God, I hope they don't see me. I hope they don't see me on Twitter.
Alms for the blind. Alms for the blind.
Yeah. But I was reading that book, Shopcraft as Soulcraft, and by Crawford, which is a good book, talking about the value of working with your hands and also the intellectual side of that. And one of the things I noticed when I came to work for HP a long time ago, we used to build everything, even the front panels, and silk screen the letters and things on it. And now they don't build anything. And I've noticed that
no, Keysight's building it, duh.
Yeah, I know. Well, but even they aren't. Actually, Keysight's in a really interesting situation, as I noticed that companies like Rigel come out with really good equipment for not much money. And I've got one of their scopes, and I've got their spectrum analyzer. And I was used to, like, with the spectrum analyzer, that was something that was, well north of $10,000 not very long ago, and now you can buy it for $1,000 or $1,500. But what happens is, they kept talking about moving up the value chain at HP and giving up things like manufacturing to low cost places like Shenzhen. But the thing is, just like the circuit board, a lot of your inspiration for the next designs come from being around the manufacturing. And if you give up the manufacturing, after you just move further and further up that pyramid till there's nothing left.
Right.
And
right.
I see
you're a consultant for consultants about how to consult, right?
Services.
Yeah, IBM are we talking about IBM too?
Well, IBM and HP both, the bean counters see a lot of, they're just really attracted to that model, I suppose, because it doesn't. I don't know. Anyway.
Well, we could pay people and make stuff and have overhead costs, or we could just pay people, and then they can make stuff up, and then let's go for that one.
Well, let me give the opposite point of view, because I used to work for AT&T and Bell Labs, and we were the poster boys for vertically integrated at the plant that I worked at, where they made telephones and customer premises equipment. They used to grind their own coal to make the microphones that went into the phones. And I mean, we did everything stem to stern. I mean, if it wasn't done by Western Electric and, in-house, then it wasn't done. We had our own ICs, we had everything. And that caused a problem later on, is when I started back in 79, we were doing a project and it needed a microprocessor in it. And the one that we selected was the Motorola 6801 with 2K of ROM and 128 bytes of RAM. I mean, we were swimming in it. But,
where will I find the opcodes? What will I do with all this opportunity?
I mean, we needed that processor and the way that it did its interrupts and the way and some of the peripherals it had on for generating waveforms, because we were generating and decoding the modem waveforms in the processor under interrupt loops. And so we needed it to be able to do that. And we had an internal group in Bell Labs that was making a 4-bit microcontroller called the Mac 4. And the problem with internal groups in AT&T was we couldn't sell outside. It was not allowed legally for us to sell anything outside and compete with outside companies. So any project that needed a microprocessor or microcontroller, this Mac 4 group was going to latch onto it because that was the only way they had to make sales. And they came in and they pitched the Mac 4 to us, and we, said, well, it doesn't do this and this. It's a 4-bit machine. We need an 8-bit machine. We need these peripherals on here. You don't have the peripherals. It won't run fast enough. It's going to cost too much also, because we not only had to pay our overhead on it, we had to pay your overhead on it as well. And
support the fab and buy the chemicals.
And we fought for months on that and had to have meetings and go back and forth on that all the time while we're trying to do the project. And then they finally admitted defeat, and then 2 weeks later they came back and said, okay, how about 2 Mac 4s in there? So we go through the whole thing again for, back and forth. No, it doesn't work. It's too much. It's too expensive. We don't know how to divide the program, blah, 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 blah. A month or two later, they finally said, okay. A week goes by and they call up, okay, how about 3 Mac 4s? And they said, just shut up. Get out the phone. And that they didn't really push that one because I think they were finally embarrassed. But about a year after my project got canceled, one of our guys met the guy that had been pushing the Mac 4s, and he said, you guys made the right choice on that, choosing the Motor 6801. And, he was embarrassed because he was in a position where he could not come out and tell the truth. He was shilling for the Mac 4 group. Yep. He couldn't say what he honestly felt, and he just had to keep going through the motions and just wasting time. Yep. And, so that's the opposite thing. When you have these captive groups in your company that have to make sales to you, then they can get in the way of you doing anything as well.
Yeah.
Well, that's like a lot of the incentive structures, right? I mean, like that guy. Yeah. It's like if you don't sell it, you're fired, right?
Yeah,
that's obvious. And then, well, let's look at your market. You've got maybe 20, 25 groups total to sell to. So
probably less than that at that time, but there weren't many microcontroller projects going on in AT&T at that time, and it was pretty thin. So, like I said, when they heard you were doing a microcontroller project, they were on you. I mean, it was like little Gonzo bird in the Muppets, and he's holding onto your leg and he won't let go.
That's awesome.
Dave Packard did say that profit was one of the best measures, certainly not the only measure, and certainly he didn't believe that it was the only measure, but he said that was one of the best measures of your contribution, though. People were buying your stuff. Yeah.
I mean, I've always said that, your mama will tell you you're beautiful, but when somebody hands you $100 for something that you've done, that's a true compliment. That's honesty right there.
Yep, exactly. Speaking of how goes the FPGA sales these days, Dave? Well, that's a weird one because I assume people are handing you hand over fist money, right? But
right, yeah. Well, they're handing me hand over fist money, which I hand over fist to my ex-wife. But we're like Bob says, keeping the lights on, and
that's right.
I've over the past half year or so, I've gotten into working with a fellow over in Portugal, Alvaro Lopez, who did the Zuprino soft core processor. So I've been kind of integrating some of his work into my boards and using that soft core processor as a kind of an open core alternative to using some of the tools from Xilinx, which are kind of closed up and not that readily available to hack on unless you buy a full license. And I mean, it's really pretty neat. It's all VHDL. It's all open, and you can slide your own peripherals into it pretty easily. And I got a recent blog post where I just show how to put a very simple RGB LED controller in there that will, just dim and light up an RGB LED with various colors and illuminations and things like that, just to show how you can make your own peripherals to do things like that and offload the processor. So all it does is every now and then goes out and pokes it and makes it do its thing, but it's not continually generating PWM waveforms on its own.
Yeah.
And so that's kind of neat to work with that stuff and to work with somebody else has offloaded a lot of the effort of doing some of the design, and it's just a matter of taking his code and putting it into a little different form and being able to use it. That's always nice to be able to take advantage of other people. And
we're going to quote that one. That one's going to go on a T-shirt. So Dave says it's always nice to take advantage of other people.
And I've also gotten a little bit involved with some of the Internet of Things in a peripheral manner. I've been playing around with some of the ESP8266 Wi-Fi boards that have been coming out.
Oh, yeah, that's the real low cost chip.
Oh, yeah. It's down to
I see that stuff on Hackaday sometimes. I'm not sure. I mean, like that's. Oh no, that's what it was. So it was someone. One of my friends actually was telling me about they pass CE, but only on certain models or something weird like that. Yeah,
and in fact, they probably really haven't passed CE at all, from what I've heard on other forums there. But it's you're looking at a device that costs now about $2.70 for a board. It has Wi-Fi on it and a programmable 32-bit microprocessor, the LX160, I think, from who is it? I can't remember, but it's one of those. Tensilica, yeah, they made it, and you can get in there, and Espressif, which is the company that's making the chip, the sock that goes on there. They've given you a full development environment. You can download a virtual machine that has all the compilers and everything in there. They give you the full source code, and people are going in there and hacking this thing out to run the MQTT protocol and run web servers and everything else. So even though it was originally intended as something you'd hook up to the serial UART lines to a microcontroller, they just, getting rid of the microcontroller externally, and they're using the one that's right on the chip itself. So
just for compactness and lower power stuff like that.
Yeah. I mean, it's not a low power device in terms, it's Wi-Fi. So you're looking at 100 milliamps or more when it's working. It's not like Bluetooth, but it is a pretty cheap way to get going. And you got to imagine some of these companies that are coming out with Wi-Fi boards now that are, that looked really, really low cost, 3 or 4 months ago. And now they're not looking so low cost anymore.
So if you don't mind my saying as much, taking a step back, I don't know how to say this right, the old guy view of IoT. Is it okay to say old guy? Can I say that for the rest of the show? Are we cool?
Sure.
Okay. I feel old guy myself a lot of the time.
I'll send you a picture.
No, Chris, you're not old guy.
No.
I know.
Quit trying to steal our thunder.
Yeah.
Old guy at heart.
We earned our old guy.
That's right. I get that. So what is the old guy view of IoT? Because I mean, like you said, so Dave, you're saying this is seems like a pretty legit entry into that. We see a lot of that crap that came out of CES. They kept talking about it. Bob, you work on Bluetooth stuff, and that's all lower energy stuff. How do you see it? I mean, like, you guys are veterans of the industry. How are you seeing this? How are you seeing it practically implemented?
I'll let Bob talk for a while.
Okay, well...
Then I'll steal his ideas.
Yeah, I don't have any ideas. I don't know. It's a lot of that's just marketing, and
agree. Yeah.
The marketing folks are really excited about it.
I think because you're right, because they take it, they bundle it into a thing, and then they call it IoT, right? But it's
and they want to combine it with.
For us, it's like we still need to deal with protocols, we still need to deal with hardware, and you can't really separate the two. It's not like everything talks to everything. It's device A talks to device B because they're both Bluetooth.
Well, yeah,
BLE, whatever.
And I think the idea of putting every sensor on the internet is kind of crazy. Mostly, the way I envision it, and the way that I actually implemented for this grape vineyard is for wine grapes, but it is, you have your local sensor network and then a gateway device of some sort that you don't put every sensor out in the...
Yeah, like hub and spoke, basically.
The
hub is doing the communication.
Yeah, and people think... They can. A lot of people are really focused on the big data side of it. The abstraction and so forth is always a good thing, and making things talk together and standards. I don't know that there needs to be, a standard for IoT. I think most of the most of what you need is there. The things that have been that I saw that was pretty exciting was Bluetooth Low Energy, and mainly because smartphones have become ubiquitous. So I think smartphones are a logical gateway device for a lot of it, and the fact that both Android and iOS support Bluetooth Low Energy natively, so you can just, if you want to hook up a sensor to an iPhone, you just do it through Bluetooth Low Energy, and you can write an app for it right away, and use the power of the smartphone to display your data and to take it up into the cloud if you need to.
Yeah.
Makes a lot of sense.
Yeah, I agree with everything Bob said. In fact, if he hadn't said it first, I would have said that.
But, I believe that. I believe that now that I hear that. Yeah.
And he's right that IoT has become quite a bit of a marketing term, and I think people are throwing it around a lot. But I really do like to see everything that's going on. I like to see the low cost, low power chips coming out. Mm-hmm. I like to see a lot of shit flying around. Because a lot of it
chaos creates, right?
Yeah, a lot of it seems to be really bad, but there's going to be a few good things in there that are really going to be great. I love the idea of being able to just plaster sensors all over bridges and have them soak up the energy that comes in and be able to rebroadcast information if there's going to be a crack developing. Stuff like that is to me just the exciting part of it. I don't really care that much about monitoring my heart rate, but
Yeah. My scale in my bathroom sends my weight out into the cloud every day, which is kind of embarrassing.
It's all this data we can just ignore on a daily basis. Bridges are falling down, weights are rising. I mean, I got that too.
That scale wouldn't last 2 days with me.
Yeah. But one of the areas that I've found pretty interesting personally is that's related to what Dave was saying, is there's a lot of really interesting work going on in energy harvesting, and there's some practical things happening. I've been working a lot with some of the linear technology parts, but everybody has their own version of it.
So delicious, so expensive.
Yeah, I know. Well,
literally, I love. No, listeners know I am a fanboy of LT parts, but man, every time I see the one piece price on like an online distributor, it's just like, holy shit! Where did they come with that number?
Yeah, they provide really good support, and the stuff just works, is what I've discovered. But the other stuff out there works too, so I don't know.
Yeah.
But the energy I'm working with this it's fairly new, LTC 3330, and it's a sort of a general purpose energy harvester. So you could hook up a solar cell or a piezo. It doesn't have quite good enough performance to work with thermoelectric generators. Maybe some of the newer ones. But
in terms of scavenging energy, Bob, what is the best source for getting that from the environment? If you had, solar is obviously a very good one, but is that the best, or is there something else better than that?
Well, solar is okay. So it gets into the practical side of it. Like some of these sensors are so low power that you can run for quite a few years on a couple of AA batteries, so there may be no point in doing energy harvesting. But in situations like if you're putting thermal sensors into power transformers up on a pole, you have it's so application specific that there's not like a general solution. But if you have a power transformer that's generate a lot of heat, so it's logical to think about doing thermoelectric generation. But this system with just a few square inches of solar cell, and I found these really neat industrial batteries that also are very expensive, but everything I'm building is very expensive.
People are going to ask for part numbers.
I know. Okay, I'll go grab it. But the neat thing about them is they have an operating range from minus 25C to 85C, which means they'll work outdoors around here.
Yeah.
Pretty well, but
not around here.
Yeah. But So solar, I guess you just have to. A lot of people have been trying to generate, or use mechanical energy to generate power, and I haven't seen a lot of successes there. I mean,
Right.
more likely the number one energy scavenging thing has been solar with some battery backup, and then after that would be probably thermoelectric generation.
Yeah, the reason I asked was maybe a week or two ago, I saw somebody talking about energy scavenging, and they were talking about how scavenging the RF in the air was just much less efficient, or much less power out there than it was from getting something from movement or thermals.
I know that you hear people get really excited about they're going to energy scavenge from all the TV signals around.
Exactly.
And but I did
How close
see
are you to the tower?
Yeah. Well, I've been working with a local university, and they have a pretty good material science department, and they've been building some thermoelectric generators, and one of their projects was scavenging waste heat off of like a Humvee, but they're generating like a kilowatt of electric power from the waste heat on one of those things.
That's legit, yeah.
So there are applications. You just have to look at each application and try to
but it's
decide.
not Wi-Fi, right? It's not like like anytime you see a Kickstarter or Indiegogo, probably.
Yeah.
So
Wasn't there the Indiegogo thing that was or what? It was being funded by somebody, actually by Horowitz and Anderson or something, with the acoustic energy they were going to beam into, your cell phone. You'd put it on there, and then the acoustic energy would go into it, and it would charge it up.
Yes, listeners of the show will know our ongoing distaste for the U-beam. U-beam is I think they've switched over to a antenna array or whatever that's called, the directed antenna stuff, but that's terrible.
One of them,
maybe
we
could just rub it on our hair and charge it with static or whatever. If I had any hair, I'd rub it on there. But
right. Well, you both have dogs, right? I mean,
I do have dogs.
dogs
and
dog
horse
hair
and
harvesting.
He is not sitting still for that shit.
Yeah, that's what the cats are for.
That's right. There you go. Yeah, just put whatever device you need, like on the keyboard, right when you're about to start writing code, and the cat will be there, ready to charge up whatever you need to charge.
By the way, these are Tadran, Tadiran, lithium inorganic batteries.
Tadiran.
Tadarian.
Sounds like something from Star Trek.
Yeah,
I know it does.
And they part number TL4935. But they have a bunch of different ones, but they're made in Israel.
That's good to know.
How much did they cost?
The battery costs about $8, so it's pretty expensive.
Ooh, yeah.
But if you're sticking this up someplace that's hard to get, then it doesn't matter.
Right. What's the cost of a technician going out to switch out the battery? Right. It's like that's always the measure. Is you have to compare those things.
Yeah. So I try to find work that justifies the expensive parts that I like to use.
That's good. No, that's really good. I think that's because that's where the interesting problems are, right?
Yeah.
I mean, you want to be able to play with the fun stuff.
Yeah.
It's like if you're like, oh well, I need to find a MOSFET that isn't 13 cents. I need to find one that's 12.5 cents.
Yeah.
Because
well, that's its own set of challenges.
Yeah,
it is, but those aren't as fun, right? It's not like we were talking the other week about me and Dave were talking the other week about the R&D type of things, right? Where is the R? Where is the D? Most people in engineering are doing development, right?
Yeah.
I mean, development is optimizing. It's finding better parts. It's like all of the things that that I think the bulk of engineers do.
Small R, big D.
Yeah, exactly. Small R, big D. It's like it's not as exciting.
Yeah.
I mean, I think research on its own is not necessarily exciting either, but ultimately the output is you save some money versus you discover something new.
Well,
and it's always tough.
The way I think about it, because I worked on a lot of technology projects, is that the technology projects take a long time, and but they should pay off over multiple generations of products. Like I worked on magnetoresistive thin film heads, and that took us 16 years before it was actually in a product. In part because the other technologies that were defending the land that they had were able to keep improving.
Yeah, keep improving.
So you didn't, a lot longer than anybody would have thought. But it's kind of what I noticed at HP, which is kind of fun because it's big enough to see different aspects of it, was it kind of sorts people too, because if you're willing to go work on something that's undefined, like a technology development project is, and are happy with that, you might feel really too constrained doing manufacturing. On the other hand, I knew people in manufacturing that were just driven crazy by the lack of definition in the technology.
Yeah. I mean, I used to work in, as a faculty member at university, and, so that's a lot of research, but I eventually left that because it was mainly looking for money and then, managing people that were doing the research for you, and you never got to really do the research. In fact, somebody told me once, he said, what faculty members really want is they don't want to be faculty members. They want to be graduate students with faculty member salaries.
Yeah.
But they don't want to be the actual faculty member doing,
right.
all the grant writing and everything else. And so that's eventually why I got out of it. But, so I'm more D now than I am R.
Yeah, I was a research professor, and you spend all your time writing grant proposals and doing very little actual work. And the other thing, well, not actual work, that grant writing has certainly worked, but the work that I wanted to do.
Be doing.
And the other thing I didn't like about it was you felt some of these writing proposals felt like you're really doing research for the granting agency. And if somebody clever at the granting agency would ask questions and get all these 100-page reports on how different people would do it, and then pick the one that they liked and go after that.
Well, the thing I always felt was that when you're writing grants, the only way to get a grant approved was you had to have it all nailed down and done before you even wrote the proposal, because you had to have, all the issues you had to have good answers for all the issues. And if you didn't, you were coming up against some other group that had been working in that area for years, and they had all the results already, and they were just writing the proposal to get money to move on to their next project, whatever that might have been.
Yeah. It's, it has its pluses and minuses. The thing that I really liked about the university is working with the students. And I've got the best of both worlds now, because my office is just on the edge of campus, and I have students that come over and want to work with me. And, but I don't have to deal with the university.
That's awesome. Yeah.
Yeah. I mean, I like the students, but I found, as a faculty member, you get a lot more students that were in there for the degree, and a lot fewer students that were in there for the learning of what was going on with the degree. And I had a student come into my office one time, and I had a book on my desk. It was about biomechanics. It was an examination of how different sizes of animals use energy, and what the effect of different sizes was on the frequencies of various things that went on in their body. And he looks at the book and says, what the hell are you looking at that for? Well, way to show some curiosity there, pal.
Yeah,
but,
right. Been to Wikipedia much?
Yeah, well,
ever been on a wiki hole?
Yeah.
It was a long time before Wikipedia, but we used to go to the library every week, and they would have a section of the library set out for all the new books that were coming in that week, and you could go through there and you could find all kinds of outrageous crap that was just interesting to read about. But and to be honest, when I was a student, I was kind of like that as well. I was very concerned with getting the right grades and making sure that the numbers were there. But it didn't take me. It took me a while to get out of school before I realized that there was more value in the knowledge than the actual grade that I was getting.
Yeah, I always thought of myself as a C student, and that worked out really well, because then I could take whatever courses I was interested in and
not worry about the grade. Yeah. Well, I'll tell you, when I look at students now, I mean, I see a lot of students grubbing for, those all A's and things like that. But, a lot of times I've said that if I were looking for a student coming out of school to work for me, I'd look for the guy that had like all F's and one A. And whatever he got that A in, that's what I'd try to get him to do for me.
It's like you don't want a brain surgeon that's well-rounded.
You want the guy that's shown some real interest in something and is willing to work on that almost to the exclusion of everything else. And, the guys that are real well-rounded and get all A's, a lot of times they can say, well, if I don't do good at this, I can always move over to, doing this over here instead. And so they don't have all their eggs in one basket, so they're not really worried that much if one basket gets broken, they've got another one to go to. It's like all those guys that say, I'm a math prodigy and also I'm a violin concerto, master. So, I can do one or the other. So they end up doing neither and both.
Yeah.
Anyway.
I think about the guys that I used to go to school with, and obviously I was not the top student. I very much recognize that. But then I think about like the guys that I know. I follow them, and obviously social media makes this easier than it used to be. But like these guys, they went to Intel, they went to like all these high end companies, and then I look at what they're doing now. And it's just like verification engineer at Intel. And it's like, dude, you're looking like I know you're great at analog circuit design, but like you were looking at one circuit over and over and over again. and some people like I think it's personality type too. I think some of it is that it's like they that might suit them really well, but I don't know. I think about what I want to do, and it's just like I want to build stuff. I want to make new things. Like. I don't know.
Yeah, I mean there are multiple ways to success, and the university really only rewards one of those ways. And so these guys were successful in the university, and now they've gotten themselves into maybe a position that they think is very good, but. You were kind of, you got out and maybe you didn't have as many opportunities as everybody else, but you made opportunities as you went along. I mean, the Ampower is a perfect example of that. And that's the kind of thing that doesn't get measured very well in an academic environment.
No, I hope not.
No, I mean, that's what I would want in a student is somebody that, makes his own opportunities. That's the thing. That's what you want, but you can't measure that in the university, and you can't assess your program based on that. And when ABET comes around to accredit your program, they can't see that. So it's kind of what you measure is what you get, and if you can't measure it, then you never get it.
That's a really good point too, because like I had forgotten that both of you guys had taught at university as well, in various capacities. So let's shift the focus there. I think that's even worth more discussion. What is your take on education these days? I mean, obviously you've already talked about what you'd like to see in a student, but where do you think we're going in the future?
As long as they stay off my lawn, I don't care.
That is the correct answer. You've chosen wisely.
Sorry.
Go ahead, Bob. Go ahead.
Oh, no, the students that I have worked with here that are really interested in the work are as good as students anywhere, and I think they're as good as people in my cohort were. So I don't know. What I really think is lacking in not so much in college education, although maybe to a certain degree, but in secondary education is the idea that, working with your hands is valuable and intellectually challenging just as much as doing some other things that are normally associated with that, like, being good at math. So and that's part of the reason why my business is set up the way it is. So any prototypes that I need, we build them here on site, and keeping my hand in that has been really, literally is really valuable in terms of design.
How do the students know to come to you in the first place, Bob?
Oh, the other professors over there know me, of course, and and they have senior projects, so they're always looking for sponsors for students for the senior project, so the well, I was just thinking about whether I should tell this story or not. But
yes, that definitely means you should. Yeah. If you have to stop and think about it, come on.
I just had a student over here the other day that just said, "Oh, well, I sure appreciate that you took the time to help me." He said, "I asked all these other people if they could help, and they were all too busy." And I wanted to say, "Well, that's because they probably didn't know." But I don't know. There's good side to what they do, of course, too. So,
well, I can tell you, a dozen stories like that. But when I was a faculty member, which was like from the late '80s to the early '90s, we get every organization has a story that it tells you that is not true. And the story that they tell faculty members is, your academic career here is based on 3 legs on a stool. Those 3 legs are research, education, and community outreach. Community outreach is helping local companies solve problems if they have them. Education is, teaching classes, just what, teaching students. And research is getting research money. Now, the thing they never tell you is that out of those 2 legs, one is a pine stump that's about 2 feet thick. And the other 2 are like little paper straws that, will not support any weight. And the research is the one, if you've got the research leg there, your stool is going to stand. If you're counting on the education and the outreach, you're going to end up with your ass on the floor. And,
that's right.
One time there was when I was married, my wife had a friend that worked at the university, and one time I come home and my wife says, "Guess what? So and so won a best outstanding teacher award." And I said, "She's gone."
Yeah.
It's sure enough, within 1 year, she was gone. They drummed her out of the department. And
really,
it's. I mean, I was
obviously she didn't have tenure or anything, right? That,
oh no,
like that,
no,
right?
no,
I mean,
no. And but it's. I mean, I was obviously being very cynical, but as I told my girlfriend once, I said, "I'll renounce cynicism when it ceases having its predictive power." And she was gone, and that's why Bob gets students funneled to him, is because for at least part of the reason is that the faculty members, they can't put that down on their resume, they can't put that down on their CV. Is I helped student X solve this problem. It can't be measured, therefore it doesn't count for anything, and but I think, getting back to Chris's original question about how students are, I think they're as good or better than they were when I was in school. And a lot of it is that they have so much more access to information than they used to before.
Yeah,
they can find
amazing.
out so much more than, we used to be stuck with whatever data books were lying around the student lounge. And now, you've got everything. And if you want to take advantage of it, you can take advantage of it.
Okay. Let's cover that then. So the Bob and Dave method, not the Bill and Dave method, the Bob and Dave method. What is the recommended path? Because I know the statistics of our show. I know who listens, right? I mean, 1/3 is students. Mm-hmm. Hello, all students out there. Good luck in your finals in a couple months. But what is the recipe for success in your minds? What is the best percentage of success? I mean, so personally, what I think about is, obviously I teach contextual electronics. I think about project-based education. I think about making stuff, right?
Yeah.
What else is part of that equation? What else is stuff that students should be doing, in or before their senior year of college, so that they can, build interesting stuff, get interesting jobs, be involved in interesting projects. What have you guys seen in your own careers that has allowed you? What has allowed you for success in your own careers?
You want to go first, Bob, so I can steal all your answers again?
Well, I was just thinking about, I was interested in this stuff from when I was pretty young, and got involved in ham radio, and got my license when I was 11 or 12, and And then that led to working as a technician. For me, I think having the hands-on experience, which I got outside of school, I got it working in a TV repair shop, and which they don't do anymore.
Yeah, what is the modern TV? So, like, again, doing interviews across lots of people, like the repair shop. Personally, I started in repair as well.
Yeah.
Like, I think Dave probably started in repair. Dave Jones, of course. What is the modern repair shop? Does it exist?
Maybe the hacker space, but there's so few of them around that it's hard to get to those.
I would say, building things, which is not so much ham radio anymore, although that's still a viable. I mean, if you're assuming you're going into something like electrical engineering, which I guess would be reasonable considering it's the amp hour.
Yeah, probably.
Writing software is fine, but I don't know. There's what I think is exciting right now for students is the idea that you can go out and for essentially zero money get involved in developing embedded hardware, which is a fairly recent development because even 15 years ago, a lot of the tools would have been out of the reach of students, if not, a small business like mine. And taking it, and the internet. There's so many great resources. YouTube. I learn a lot from watching people's, like what you do, Chris, or what Dave does. And I don't know, get out there and build things and network with people and learn about.
I've got to echo that about what Bob has said there. I mean, when I was a student, 74 to 78, which is quite a while ago, it was all grades. I mean, you had to grub for me, and the only way I was going to get interviewed to join Bell Labs is if I had just fantastic grades. If I had B's and C's in there, I was going to make that. And that, that was back then. But nowadays, to me, that just seems like a death sentence to be concerned about the grades. The first thing you should be doing, I mean, the only thing you should be really concerned about in your undergraduate is build stuff. I mean, you should be
portfolio style,
you should be looking for every opportunity to build stuff. If your classes don't have you building stuff, you should be building stuff on your own. You should be finding other people in your class that build stuff. You should be building stuff together. You should be building stuff on your own. Yep. And if your grades suffer, then I say so be it. And that's better. Yep. That's better than coming out. I mean, if a company won't interview you because of your grades, but you've been building stuff, that's not a company you want to work for. I don't think that nowadays, I think that's true. And I mean, if you don't build physical things, build software, build something. Because that's where everything comes together. It's when you have to build something and make it work.
Yeah.
And it's so cheap now. I mean, you've got so much access to so much stuff that, $10 microcontroller boards that, have 32-bit microprocessors with a megabyte of RAM on them, Raspberry Pis and everything else. You've got no excuse anymore not to build stuff. But professors do not like you building stuff. Just at least when I was there, because I mean,
they can't.
They can, but that. I mean, it's what you it's what you get measured by. You don't get measured by building stuff. You get measured by writing papers and finding students to write papers and, funding research projects and, all great stuff. We need research, obviously. But, if you're the undergraduate student and you want to come out with an education, what they need to do for their career is not what you need to do for your career. You've got to show initiative and build stuff. The
thing is, you need both the sort of academic learning, but there's a lot of subtleties, and when you go to build things, that you'll find out
about project boxes and everything else.
Yeah.
No offense.
No offense taken.
I made that mistake so many times. I'm laughing at myself. Really.
Yeah. Oh no! You have to be able to laugh at yourself.
Crap! That's honestly what I'm thinking in my head right now.
Yeah. I was going to say that having that desire to do it, versus just deciding what's going to make you the most money as a outside in your career, is a big indicator of who's going to be successful. If people are doing it because they just want to do it, in fact, not want to do it, they sort of almost have to do it, and there's nothing that could keep them from doing it. That those people will do a lot better than the people that just look at all the different possibilities and decide on electrical engineering because that has the highest income. Doing things that are hard to do is always good because those act like barriers to entry, and then usually getting paid well follows that.
Hey, you're shitty at this. You get an F.
Yeah, I know.
Well,
this is now a barrier.
Yeah,
it's like what they said on Adventure Time. Sucking at something is the first step to being kind of sort of good at something.
Yeah, you really have to be willing to take risks, and part of it is being willing to fail. And like I was only half joking when I said that I thought of myself as a C student, because if you are the sort of person that has to have an A, then you'll usually, be cautious about what courses you take.
Exactly.
And of course, my dad sent me all my report cards from elementary school, and I was looking through them, and they had interesting comments like Robert has to be separated from the other children. He would rather fiddle with clay than pay attention, and looks out the window.
Sounds right. Yep.
So anyway,
I think throughout the ages, the only thing that changes is clay gets replaced with Legos, and gets replaced with Arduino and everything else, right? I mean, I think these are just the non-permanent thing is the item being fiddled with, right?
Yeah.
So the other question I wanted to talk to you guys about is, so you were talking about the need between fiddling on your own and that kind of idea, and one thing we had talked about over email, the balance between being in a small company versus a big company, and or even being on your own. And I'd be kind of interested about how you guys feel about that. I mean, you've both been in the big organization, been in the small organization, been on your own. How have you balanced that, and how do you see that balancing going forwards? How do you see people acting as individual agents or as part of an organization going forwards?
Well, certainly individual agency has become much more possible, over the years than it was, quite a while ago. But I started off in AT&T at Bell Labs, and, that was just awful. I mean, we had, because
that's pretty much like we talked to Shariar as well, right? He's part of Bell Labs still. Like, it sounds awesome in parts of it, right?
Yeah.
Like, the parts are like the research and the being around smart people. That part's great.
Yeah.
But
that'll last you 2 weeks right there. But it'll get to you after that. The problem that we had where I was is, we had a lab that was almost, when I left it was almost 500 people. And I think I could count on the fingers of one amputated hand the number of projects that actually went out and became real products that people could buy, and use, because it was start a project, start a product, get people on it, work it for 2 years, cancel. I mean, it was over and over and over. I mean, we even had a song that we would go by and sing to people when their project was canceled, because it was just so common that we just had to have, we came up with something, and it was just, and it seemed,
wait, hold on.
I
think Bob will agree with me that we need to hear this song, right? Bob,
yeah.
I mean,
come on. Do you really want to hear this?
Yeah,
thing?
No, I really want to hear it.
It's only like 4 verses.
I don't care. No,
this is a song that Ron Meyer.
We'll pretend we're going to edit it out, but we're not going to.
Yeah, please. This is. I mean, when I sing, my girlfriend's daughter says, "Oh, please stop." This is a song that Ron Meyer and I came up with, and it was sung to the tune of Johnny Carson's theme song, which probably nobody listening to this remembers except for me and Bob.
Yeah.
But
what's the theme song? Because I don't know the theme song, but
the theme tune, or it didn't have any words to it, but it was, and Johnny'd come out and he'd do his golf swing and that kind of thing. But so Ron and I sat down one day and we heard about a project get canceled, and I said, we ought to have a song for that. So we started, sitting in our office. He said, your project's canceled. That's what comes after that. So he said, your project's canceled. You're out of a job. You thought you were hot shit, but you were dead wrong. That's about as far as we got until somebody in management came by and broke it up. But yeah, I mean, it was just like 2 years, and you were done. And it's like management. I'd like to think they had a concrete reason for canceling it, but a lot of times it looked like they just got bored. They said, we've been working on this for a while. Let's just can this. And
something new,
there's something neat to do. Let's do this over here.
Yeah.
And it's just so debilitating after a while. It's just tough.
One thing that we used to do at HP that worked pretty well in the old HP was something called the next bench syndrome of product development. But the idea was that you'd develop a tool for some problem that you wanted to solve, and you'd develop a tool that would solve a problem for the guy over on the next bench. You'd find customers, and you could check whether you were doing something that was to be worthwhile or not pretty quickly. By finding local customers and getting that feedback. But that whole thing gets into, because I was on, several projects that were canceled as well. In fact, the one technology project that we worked on for 16 years before it actually got into a product. But it just brings up the idea that you've got...
they would never have gone 16 years around.
Yeah. Well,
wouldn't have gone 16 months.
It got canceled several times, but I just kept figuring out ways to stay involved with it. So
you rename it each time. You're rebranding, right?
But no, there was good reasons for why it happened the way it did. But the thing is that what makes a thing a success is not just the idea, but also the execution. And part of the execution is, making sure that you're addressing a real problem for people. And that could be where it gets a little bit lost in big companies. One of the things about big companies is that, well, there are certainly a lot of things that require a big organization to do that an individual or a small group of people probably couldn't do on their own. And mostly it revolves around setting standards for things. But anyway,
exactly.
Standards are definitely important. I mean, PCs didn't take off till Microsoft kind of got set as the de facto standard.
Right.
But
it takes a lot of money too. I think that's kind
a
of
lot
an
of money,
thing, right? A lot of people. And I mean, maybe not these days, but I think.
I think there's still projects, like if you're building a rocket to go to the moon, 10 guys are not going to do that. But
right, yeah, SpaceX is not a small organization by any stretch.
But it's smaller than what NASA originally started off as.
Yeah, that's true. But it also doesn't have all the spurious. I mean, like it seems like the Bell Labs project you talked about, Dave, were like the. Like I hear about NASA has a research center in Cleveland, like the NASA Glenn. And I hear about that stuff, and it's like, we're talking about lasers and all these other things. It's just like, what the hell does that have to do with going to space? Like, I get it. It's cool. It's awesome. It's probably related to the future. But it's not about launching a thing into space. It's not like getting out of Earth's gravity's pull, right?
Yeah, it's probably, something that they're working on in concert with another, government lab, and they're able to share some funding on this or something like that.
And that's where it is. It's the money aspect, right?
Yeah, they got to get money in the door, and that's the way to do it.
Yep.
But, talking about, big companies, the thing about big companies is, when you're a small company, think of it in terms of cell size. When you're a little tiny company, like a little cell, most of you is surface area. So that means that everybody in the company is kind of like on the surface, and they're all seeing, the application for whatever they're doing. They're interacting with customers. They have a pretty much a direct line to the lifeblood of the company.
Everybody has a Twitter account. Everybody is listed as the main contact.
Yeah,
right?
and you see the customers, and you see what's going on, and you see this is how I impact this. And if I don't do this, then it's going to have a bad impact. If I do this, then it's going to have a good impact. But, when you get into being a big company, and then you're a great big cell, and then you have the surface area to volume ratio is going down a lot. Now there's only a smaller portion of people on the surface that see where the
now
rubber
the
meets
goddamn
the road.
Mitochondria, right?
Yeah, and now you're stuck over there in the goddamn endoplasmic reticulum, and you're saying, well, what the hell am I doing over here? So you say, well, I don't look very important over here, just, combining these little molecules. I better grab some more bigger molecules, and, maybe I can gum up the works over here for a while.
I should friggin' mutate.
Yeah.
I should replicate quickly.
Yeah, I'm gonna divide this nucleus. You see if I don't. And
that's right.
And it just, then they have to do things to justify their own their own position. And again, it gets back to what you measure is what you get. And you have a hard time measuring those internals in there. So they have to do something. So they start doing things that can be measured. And that's where everything kind of goes to hell. I mean, with a small company, if you miss the ball and it goes between your legs, it's going to roll all the way to the outfield wall, and that's what you worry about. But with a big company, it's like what you're worried about is one of your teammates is going to grab ball and he's going to throw it into the outfield fence, and then he's going to blame it on you.
That's right.
So there's some good things about big companies in terms of being able to get hold of those big means of production and having some significance out there. But there's a lot of it comes with a lot of negative things as well that you have to, that can be very debilitating.
If you get in the right situation in a big company, it can be pretty nice.
Like CEO.
Well, I was thinking about when I was working at HP Labs, but CEO would be nice too. It'd be more lucrative.
Someday,
But
we aspire to that.
And a small company has its downsides too, because you got to do everything. So I've got a lot of bookkeeping to do that I don't necessarily like, but you have to do that. And
or when the U.S. Post Office decides to change its web interface for figuring out, postal fees for shipping packages, and then they send you an email and they say, "Oh God, here I go."
Yeah.
Did you guys ever think when you were in school for electronics and stuff like that, you'd be like, and someday I will be worrying about what the best logistical option for the widget that I took, the thing that took me 20 hours to develop and debug now takes me 100 hours to ship and optimize logistically.
Well, I mean, that's part of the fun part of it, is doing everything, if you like that, on the other hand. Yeah.
I mean, there's a lot of, I've learned a lot about managing a website. A lot of that I like, but a lot of that I don't like, especially when it goes down because, some service provider is not doing their, has changed his interface to me, and that's a problem. And then things are offline again. But, probably it's a good thing that we can't really see into the future. And it's probably also a good thing that we can't revise our past. But,
Yeah. Well, so Bob, so the reason this whole conversation, listeners, this whole conversation started because Bob and Dave on Twitter were talking about this stuff, and it was about possibly moving from smaller private enterprise back into a larger corporate enterprise, and kind of that discussion. And so
there are days that seems appealing.
Well, yeah, it's kind of a grass is greener thing, right? I mean, so let's talk about that from an engineering perspective. Is there one you prefer over the other, or so say you had a intern coming to work for you, and then after they were done, they're like, all right, I'm gonna go to look for a job now. What do you recommend to them? What is the thing that you say this is your best shot going forward in 2015?
Mm-hmm. Oh gosh.
Your best shot.
Come on, guys! I need a job. Give me a job. Come on, guys.
Well, I think you can go work for a big company and learn a lot of things, and then go out on your own if you want to later. I don't think it's changed from when I was starting out a lot. I mean, there's a lot of opportunity in big companies right now, and in fact, it's probably easier as a young person to get hired into a big company right now.
Once you get a few years on you, they would probably rather pass on you because you kind of know what they're all about, and they can't run the same game.
I think you're old and in the way.
Yeah, well, you're old, expensive, and in the way, and you don't take shit anymore. So
yeah. Personally, for me, the sweet spot was you always see the job listings of like 2 to 5 years. That was the big one.
Yeah.
It's like if you have that 2 to 5 years in the relevant field that you want to eventually be into, like, you're going to get a pretty decent offer, and then from there you can kind of turn that around however much. But I think then once you're past the 10-year mark, it's like, oh, well, this is a grizzled veteran.
Yeah, well, that's because they have
say that to a doctor, right? It's like...
Yeah, that's because they have 20-year-old political science majors in the HR department or something.
Right.
Right.
Exactly.
There's a lot of stereotypes of engineers, too.
Yeah.
It's true, yeah.
I mean, you know, your best bet is to have somebody on the inside that is technical, that will grease the way for you.
Networking's essential.
Yeah, and that gets back to being visible online nowadays. And
what is the way that you guys define? How would you go about networking these days?
I'm not a good person to ask that question.
I'd do the best work that I could, the best that I could talk about, and I would put it out online and try to find other people that have problems and try to help them solve those problems. And also when people get in contact with you and ask for help on things, make sure you give them a hand to try to help them out. But, also look out for the student or the person that just wants you to do the whole project for them.
Yeah.
And, don't get roped into that. But
what I was thinking about also was this whole idea of open source and the idea of publishing all the details and helping people. And what I've found is I get back a lot more than I put out there. And I try to be a good citizen, but that's just the way it works, because there's when I try to explain that to people who think about more of the traditional approach, which is to patent everything and keep all your intellectual property secret. They just don't get the idea of open source. But
patents are like, what they say is $10,000 to get a patent, but $100,000 to defend it for the first time, and then it's worth something.
Yeah. That's another thing. If in a startup, I wouldn't really. I mean, you have to protect your intellectual property, but I wouldn't put my emphasis there or think that I was gonna, keep everybody out because of my great IP. I always tell people, because I get a lot of people who are interested in doing startups coming around too, and I've had some major failures as startups, and that's where I learned the most. It was really painful, but one of the things that's really important to keep in mind is that the value of something is really the idea times the execution. And if you have a great idea but poor execution, that's not worth very much.
Right.
And so learning to execute is critical.
Right. And the thing is, especially when you're executing on products that are going out to people, is that 90% of your execution better be in the last 10% of that project, because that's when it fails.
Like the box that it goes in and the response emails, or what?
No, not the box, but at least
I mean, that stuff matters still, right? I mean,
it does matter, but the experience the customer is going to have when he unpacks that product and tries to get that thing to work, is that going to be an easy thing or a hard thing? And how many, they say that every slight bump in terms of getting from start to finish there costs you 30% of the people that would use it. So if you have 3 bumps on the way, then you've lost 90% of who's going to use it. And, and those bumps don't have to be very big, like, I need a 3.3 volt AC power supply to run my board. Who has one of those sitting around? That's a bump, and then you lose, people throw it in the side and the desk drawer and say, I'll get back to that when I get my 3.3 volt AC power supply. And, then another bump comes after that where, you don't have a certain library installed. There's another bump, and then it just keeps on going. And that's where a lot of your customer support calls come from, is just, those little bumps that come along, and you better fix them, or else, they may seem mundane and they may not seem like they take a lot of brain power to fix, but if you don't pay attention to them, they just eat you up.
I was talking to my buddy who has a 3D printing company business. He prints out, parts of a 3D printer and ships them to people. Mm-hmm. And we were talking about a lot of that. It was just like a lot of the times it's the supporting and the hand holding that'll get you the most sales. So that's going to be what gets you the bulk of things. And it's not about how great your printer is. It's not about how great your electronics are. It's about how well you support the customer. And that's I've never heard of anything like that in a school or anywhere online. I mean, like, you just don't learn that until you're in it and you're in the thick of it, right?
Mm-hmm. Part of it's because school is very much individual, getting information into your brain, and there's not a lot of teamwork. That's one thing that school should have more of, and actually the school does have a certain amount of in some places, some places more than others, but
about 20 years ago, when we went through an ABET review at my school, they were just starting to emphasize design projects and design teams in the senior year capstone courses, and that's important, and that's a lot. There's a lot more of that now than there used to be, but at least when I was there, they just that work was scut work. If you're a professor, you did not want to get involved with that stuff. So they tried to push all the senior design projects onto like one or two guys. And, they were adjunct faculty because, they didn't have to publish research or anything like that, and they could handle that. And they just burned those guys out. I mean, they were doing, great work helping the students, and everybody loved them, but they just get burned out by it all.
Yep.
Yeah.
But yeah, those team designs are really important for students, and it's building stuff, which is always important.
Yeah, that's the real world stuff, right? I mean, that's kind of
it makes the academic stuff, it gives you a place to use it and see why it's useful, and I mean, we talk about that, that's being talked about a lot more in terms of getting students into engineering, right? You got to make it seem applicable somehow. It can't just be sit down and do your math and then there you go. I mean, everybody has a problem with that, but so you have to have some application, and if you have to provide it on your own, then so be it. And having hacker spaces inside a university would also be a great thing to have. Because that would offload some of the professors having to do all the work.
I don't remember. Are you guys Hackerspace members in your local areas?
I don't have one close enough to me. The closest one is over in Durham, which is about 40 miles away. Just can't make it there often enough to make it worthwhile.
In the boonies, huh?
Yeah.
I'm out in Idaho. But we do have a hackers.
Idaho is just boonies.
Yeah. You're close to a university, right? You said you were across the street from a university.
Well, up the hill. But we do have a hacker space here in Boise. I've been involved with it. My biggest problem is time these days, because I also have, 3 kids and horses and dogs and all that kind of stuff. So
gotta get rid of those, Bob.
Oh.
Well, the kids, the horses and the dogs are awesome, right?
Can you get the dogs to eat the kids?
Yeah, the problem is the kids keep coming back. I keep thinking they're going to go out into the wide world, and then they come back.
Feed yourselves, good Lord!
I was thinking that
move, Bob, move.
I know. They keep finding me. That's the problem.
Stop attaching your location to Twitter,
man.
It'll help,
There is a big difference between different companies too, because one of the things about just switching subject real quickly, but one of the things about a smaller company or a company that's not publicly traded is it's oftentimes a lot more clear at the end of the day what you did. How it advanced the company, especially in a small company or a startup, that's real clear. Mm-hmm. In a big company like HP, you could do great work and the stock could still go in the tank because it's driven mostly by what's going on in Wall Street. And
especially nowadays.
Yeah, so that's pretty frustrating. It also drives a lot of bad behavior in the bigger companies, but that's a whole nother subject.
Well, you're talking about working at HP. I'll give you one compliment, is that at my Bell Labs location, the department heads would take a page out of HP's book, and they would do the management by walking around thing.
Yeah.
And, yeah. I mean, that was helpful. I mean,
management by wandering around.
Yeah.
Actually, there's
Oh,
sorry.
Go ahead.
Oh, there's a wonderful video that was put out, and I wish I should just put up on YouTube and then ask permission later. But it was done by HP, but it was a retrospective of Bill and Dave, and a lot of historical footage, and a lot of them discussing why they did what they did. And it's very different than the HP of today. Once they weren't involved in it anymore. Actually, the thing is, between Bill Hewlett and Dave Packard and I, we used to have over 50% of the company ownership. And
oh yeah, did you tip them over that edge?
Right.
Good for you, man. You know what? That 3-person team is unstoppable.
Right. But but as soon as it became mostly driven by Wall Street, it really changed things.
Computers and everything.
And then
else,
you get this class of people that are kind of like pirates that are on the board of directors and scratching each other's back, and it's not good.
Oh yeah.
That's why I was thinking there are. On the other hand, I've found companies, and an example is Seagate, which is a pretty big company, but it really runs a lot like the old HP. It's also a private company, so they can have a longer term view. That's the thing about the publicly traded companies. They tend to be driven by the next quarter's results, and they do screwy things to make the numbers look good. I remember one. Sorry.
Oh, I mean that's really a result of that's the result of good intentions on or unintended consequences and good intentions. Is that long ago when companies were sold stocks and bonds in themselves, then they would take the money from the investor and then they just go off and do whatever the hell they wanted. And finally, Congress got involved in that, and then they made you have a legal responsibility that you had to maximize shareholder value. And so when you turn around, this is what you get. And so you got to be careful about good intentions.
Well,
but anyway,
yeah, right.
Yeah, you got to be careful what you measure, because people tend to behave according to how you measure people, because they'll behave according to how they're measured.
Well, and how you incentivize them too, right? Because ultimately, that's what it comes down to: is what is that person's paycheck? It's like if the CEO gets a 20% bonus on a $10 million salary, it's like, oh shit,
yeah, but
$2.5 million extra to fire 1,000 workers, like, well, I don't really talk to them. But the older way of doing it was, here's your pink slip.
But if your shareholders can sue you because they think they're making 18% when they really could be making 20, then as a CEO, if your job is on the line all the time, based looking at that shotgun point of that, you're gonna give them exactly what they want, what they can measure, and everything else be damned with it. So that's why you get into these situations. Right. But anyway,
and ultimately we talked about the research dollars there, right? Because ultimately that's what drives a lot of the engineering stuff. Is that's kind of the first thing to go, is like, well, we cannot take this risk. It's always about risk, and we can't take this risk this quarter, and blah 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 blah. And that's when all the interesting problems go away, because we're just going to rest on our laurels and keep just maximizing shareholder value by reducing costs, blah blah blah. And it's like, as an engineer, okay, maybe I hold stock in the company I work for, but ultimately what I care about is are interesting problems coming down the pipeline. Do I get to work on interesting stuff? And that really hurts when that doesn't happen.
Well, there's a book written by a guy named Quigley, which is something about the collapse of civilizations or the ascent of civilizations or something. And he points out that any civilization that is rising has 3 things going for it. It has people that are incentivized to innovate. It has surplus resources that don't have to be used today, and it has an agency somewhere that is willing to invest that surplus into those innovative ideas. And what you see in a lot of companies is they have the surplus and they have people with the innovative ideas, but they're not willing to put the investment into those innovative ideas, and that's when the companies start dying off.
And that's what you hate to see, right? I mean, like, obviously, Dave, you work for Bell Labs. I mean, Bob working for HP. Like, we've seen that in both of them, right? Mm-hmm. Like, there are still, pockets of innovation, interesting things, but it's like, it's just about ultimately what are the long-term goals, or maybe even what are the the absence of long-term goals in the blind chase after interesting things, you know, like that. It's hard. I mean, like, it's hard with that focus on the profit side of things, because ultimately the things that create the longest term value are going to be the things that are never ever going to be a good decision short term. Right? The semiconductor would never have been invented otherwise.
Yeah, you had to have a guy with some vision there, but I mean, when AT&T was broken up by Judge Green back in, with the consent decree back in the early 80s, all the divisions just went spinning out into different places, and we ended up in a company called I think American Bell, and they gave us all keychains on the day we joined that company. We were in the same place, but it was a new company, kind of like different trees, same monkeys. And so they gave us these key chains, and about a year after that, it's when I left the company, but and years later I still had the keychain, and I used to take that out and I'd show it to people. I'd say, you see this keychain? This keychain lasted 5 years longer than the company did. The company was gone in a year, and it was reabsorbed into something else, and just people, they just mismanage things. They think that they know what's going to happen when they get out in the competitive world, and they don't. They weren't ready to be out there. But anyway, that's big companies.
Yeah. So the last question I wanted to ask you guys, I know this is very, very nebulous, but where do good ideas for electronics come from? Where do you guys draw inspiration from? Where do you when you're thinking about a new project, what are the resources you use? What are what do you draw upon in order to find new innovations?
I look for what's close to what. I have a lot of things. They're kind of scattered around, and I say, well, what's close to what? What, here's this thing, here's that thing. Can they be put together somehow? Do they cooperate with each other in some way? Are they completely different? If they're completely different, how do I make them work with each other? Does it even make sense? And you get a lot of really bad ideas. But every now and then one of them works out, and you can develop a little bit. But it's just a matter of being around a lot of stuff, and I've got a lot of stuff on the internet that comes flying in every day, through Feedly, and you look at it and say, that's interesting. This guy's taken this and this, and he's done this with it. So how does that apply? So most of my stuff is, kind of application oriented. It's not research oriented. It's development oriented. How do I put things together? How do I make something that's going to be useful to somebody else?
Yeah.
Yeah.
I think I try to find problems that people have, and then see if there's a solution to it in the things that I'm working on and interested in. It's really tough, and a lot of it, we were talking about Internet of Things earlier. A lot of this stuff, a lot of technology is just a solution looking for a problem, and that's a terrible place to be.
Right. It's like cognitive surplus plus money surplus plus whatever else.
So I guess you have to be. I was trying to think of the word, but gregarious enough, talking to people and testing ideas that you might have. I mean, for example, one of the things that I got involved with early on in this company was developing a system to measure how hard football players get hit. And
you won an award for that.
I got an award for that. But it has not sold, and part of the reason is because that industry reminds me a lot of the tobacco industry. They're just in denial about concussions.
They don't want to admit they have.
And so we had, a device that...
Well, people probably just get dumber over time. It's probably not about the, full contact.
What they say actually is even more insidious, and it's exactly like tobacco industry. They say, well, we know that concussions are a problem, but the science is not yet good enough to really set us.
Oh my God. Well, this is a personal choice that they make on their own, and there's nothing addictive about the money involved in football.
So even if you find a problem that you think is a good one to solve, unless everybody else agrees, it's just not.
If you can't sell, I mean, you're trying to sell that to schools, right?
Well, mostly moms, probably.
Yeah, I mean, is this the kind of thing that's small enough and easy enough to install that somebody could buy one and install it in their own helmet?
The thing is, actually, it just the one that I was working on, the version of it went in the chin cup, and it does a great job. And I spent a lot of time at Wayne State University in the injury biomechanics lab, and also another company called Biokinetics testing this thing. And we used a thing called the head injury criteria, which was developed for studying blunt force trauma and automobile accidents and has a history that goes back to the 50s. But then you try to sell it to a sporting good company, and everybody's worried about getting sued, of course. But then you hear people in the...
What are they worried about getting sued about?
They might be worried because you say this detects concussions, and it doesn't detect concussions. All it detects is that you got hit. You got to hit at a level where 50% of the population would get a concussion if they got hit at that level.
Right.
There's microscopic details about the brain that's in individual differences that make a big difference as well. And just a lot of details and things that you can't control. But with the head injury criteria, you can set it at a level that says, well, we'll alert you if you get hit at a level where 50% of the people would have a concussion. And then the idea is that you go off the field and they check you to make sure. But the protocol now, if you do get a concussion, is to rest for a fairly long period of time.
Yeah, it's a long time.
So if you're a senior in high school, there's just a lot of motivations to not, they just don't want to know, because if you're a senior in high school, you could miss most of the season and not get a scholarship.
Have you actually tried, have you actually thought about or looked at actually selling these things to the parents of the kids?
Well, I did the work as I developed the product for a sporting good company back. I know that they spent a lot of time trying to figure out how to gain traction, and they just haven't. And I don't think it's because they're not good at selling stuff, because they sell a lot of other stuff. But
because if I was a parent, I would want to know.
Yeah, I know.
Even if my school didn't, I'd want to know.
Well, in Idaho, there's actually a law that says that if you get a concussion, you have to, take care of it. But there's just not it's the parents and the students, and it's everybody. And at the pro level, there's a lot of money. The money is probably at risk at every level. But anyway, it's just so you can have a great idea that's solving a real problem in the world and still not make.
Maybe should go and start marketing it to the soccer people, because they're always hitting things with their heads.
Yeah, any sport, I think you're going to run into the same trouble.
Yeah. But who knows? Those Europeans, they might.
Yeah, they might. But so there's a lot of things outside of your control that determine success. And a lot of times the business pornography industry always writes it in a real linear way. I did this and this and this, and then I was hugely successful. And you get the idea, well, if I just did the same thing in the same order, I would also be successul.
Right. It's like a formula, right? So,
but it doesn't work that way. And people don't give enough credit to, sort of the serendipity that.
Yeah. And the other thing is what we've learned from TV is, aim for that lowest common denominator. I always tell people, that, hey, you develop, a neat electronic thing there, but, nobody's going to buy that because it doesn't have an LED that's flashing on it or something like that. I mean, I hate to say that about people, but that's the way a lot of people are. If it's not flashing an LED, it just doesn't get over the threshold, no matter what else it's doing.
Yeah.
And it's just kind of a weird mindset, especially in people that are pretty smart in what they're doing, that sometimes you need to have, that little bauble that attracts the bird, and then he'll bite on it and he'll swallow it.
Yeah, it's tough too. I mean, like it's the broad-based marketing side of things, right? It's like you kind of have to make a decision up front. It's like, okay, I know this is going to be a niche product. It's not going to appeal to the masses, and you have to be okay with that, right?
Yeah.
And you have to be like, okay, this is meant for a very specific group. And you can't be drawn in by all the BS online about, oh, well, if you're a startup and what if you got 10 million page views, and then of that 10 million page views, 1 million people brought your product at $10, you'd have $10 million. I could be rich. And it doesn't work like that. It's like you have to, if you're going to pick especially for hardware, I think, and especially for this kind of niche hardware, it's like, you have to solve a problem, right? That's ultimately that's what we're on this planet for, is to solve. Engineers as an archetype is that we're on this planet to solve problems. Pick a problem, go solve it, figure out the money later. That's ultimately what it comes down to.
Right. You've got to be interested in your solution before you can try to interest anybody else in it. If you're not interested in solving the problem, then chances are you won't be able to interest anybody else. A marketer may be able to do that, but you wouldn't.
Right.
Flipping it around, you could say that if you can work on lots of different things, why not work on the things that people are interested in?
Yeah, if you know what those things are. And it's hard to get people sometimes to tell you what they're interested in, because they don't know that they would be interested in it because they've never seen it before. Like the old Henry Ford quote, if I'd asked people what they wanted, they would have said a faster horse.
Yeah, better buggy whips.
Yeah.
That's right.
Yeah.
Yeah. No, that's a good point. And I mean, like that, and that, especially I think, like we've been kind of talking about that divide between small company, big company, especially when you're on your own as a small company. It's like, you don't have the time, but maybe even more so, you don't have unless you're already in the marketplace, solving a problem. It's not like you can go out and just query a bunch of, 1,000 people, well, what do you need? And then collecting the best responses. Oh, this will be the most profitable. It's like, no, it's like you have to kind of just test and go. Yeah, it's so I think the best case scenario.
Yeah, it's like your interview with Eric Ries. You've got to get that first viable product out there to try to get an assessment of what's going on, and make sure it has enough of the qualities that you're trying to test that you can tell whether people like it or not.
Yeah. Are you guys practicing the lean hardware? Are you in the lean hardware movement? Obviously, Bob, you had the hardware that didn't go into the box, so you had to turn it quickly, right?
Actually, it's easier to do that now than it's ever been. Again, because I can send off files and get boards back, and a lot of it has to do with how much you're willing to pay. Because if I'm doing my own stuff, more hobby type stuff or low priority. For my business, then I'll go through OSH Park and get boards in a week or so, or maybe 2 weeks. If on the other hand, for some of my higher priority stuff, I'll go through a company called Sunstone over in Portland, and I'll pay $500 or $700 and get, overnight or 2-day turnaround.
Yeah.
And,
yep.
Yeah, so being able to turn design. You can't turn designs too quickly in hardware, not like you can in software. But
the other thing is all the ancillary stuff that goes around the hardware is, you have to have some documentation, or it's something that tells tells people how to use it. And if the documentation isn't very good, you can get those first adopters to use it. But, if you're going toward the standard user, any bump costs you 30% right there. And so you have to generate these other things that go along, and especially if you have to generate software that has to be used with your hardware, then the software has to work on various OSs. Some guys are going to be Linux, some guys are going to be Windows, and then, you get a few real weirdos that are on OS X or something like that.
That would be me.
Both you guys then.
Oh, well, yeah. It's just Unix. I prefer to think of it. It's just Unix. Well, come on, man.
Yeah, I try not to get religious about operating systems. They just pick the one that does the job. Yeah.
No, that's a good point though about like all the other stuff. I mean, like especially when you think about turnaround time for developing hardware, it's like, I mean, even just like the ordering of parts, right? The generate a bomb, okay, that's fine. Go buy all the parts. Like just getting through a single purchase of parts and just verifying, because you don't want to miss that one resistor, that 4.245K resistor that you really, really, really need. It's just like, oh, it's terrible.
I had Seed Studio do me a turnkey board a couple of years ago. And the board has, maybe 15 components on it, something like that. It's not real complicated. But, to get the turnkey done and to get them shipped here and get them, that's 2 months right there. So
2 months, wow.
Yeah, it was.
I mean, back and forth and everything else. I don't want to say anything against Seed. They do good stuff, but
it was near the beginning of the year, so we've got Chinese New Year's things coming in there. Some issues there as well, but still takes them.
That's
a
good
while.
Reminder. Remember, people, February. February is Chinese New Year.
Slow boat to China.
Yep.
But, mostly for small proto runs and everything, I'm just doing the self-assembly, myself, because, if you need 20 or 30 units, you can do that and get them out there and have people look at them. But, if you get higher than that, then you need to have somebody do that for you.
Luckily, there's a lot of local, at least here, I've got two really good contract manufacturers that I could rely on to do sort of middle size, thousands type manufacturing, and because it's all automated, it's actually the cost advantage of going to China is sort of going away.
Right.
Yeah. What do you care to share the names of those, or do you want to keep? Oh no,
it's not
safe?
Really a secret. So Western Electronics is one, and another one that I really like is Computrol, and Computrol is an really interesting. Privately held company, and it was actually started by some HP engineers who went out to build a fish finder, and their motto was "Fish found by sound." And so the Computrol factory, they have a big tank where they used to test it's probably 20 feet deep, and they keep goldfish in it, so they can still, so you could see them on the. But they're excellent, and they have a prototype line, pick and place prototype line that you can build on. It's still a lot. So the shortest lead time, if I need 2 or 3 pieces of something, is to build it myself, and I've set myself up so I can do that with my own, stencil machine and reflow ovens and things like that. But all tabletop. I really want to get a tabletop pick and place, but
going
for the that TMS 280 or whatever that
something
thing is.
Something like that would be awesome.
I knew one guy that got that got a low cost pick and place, and I guess he bought it. It was a demo unit or whatever, so he got it for a pretty good deal. And I think that after half a year or so, he was deciding he was going to sell that back, get rid of it. It was just such a pain to swap reels and set it up for each job that he just said, I'm losing money on this thing.
I'm actually pretty good at placing it with a pair of tweezers.
Yeah, right. I mean, it's like the human element is like, where is that threshold of where you cross over?
While we were talking, I just placed some 32-pin QFN parts, and
that's what you've been doing this whole time? Jesus, man.
And look, it turned out
that does not show the proper respect for the show right there.
Oh, well, that actually shows the perfect amount of respect. If you're not drinking and or placing parts during the show.
I'm drinking and placing parts. And talking to you guys.
Good. Dave, you're lagging behind here, man.
Geez, all I've done here is pour all my energy into the microphone here. You guys have been sitting there making money. Probably dealing online stock trading.
I'm sinking money here.
Yeah.
Oh, and I tweeted it while I was in the middle of the show too.
Oh man, really?
Damn.
Jeez. These guys right here.
Yeah. Oh wait, let me see if I can find it. Let's see it. Talking to two assholes. Is that the one?
Exactly.
Yeah. No, I mean that's good about the personal prototyping stuff. That's important, right? I mean that's that crossover point is really it's tough to figure that out too, especially until you figure that where that point is. I mean, we saw this week. I don't know if you guys saw the Cellier article. I thought that was good to bring up now versus next week. But like those guys, they bought a pick and place. That was for a larger operation for the logic stuff. But like, they wrote about it, which was really nice for all the rest of us. But it's tough, like actually getting a pick and place in house. Like you're going to be spending months and months and months of that time just focused. You become a process engineer. You don't become an electrical engineer.
Right.
You're a process engineer.
Right.
You care about thicknesses of solder paste. You care about like accuracy to the mill of placement, and rotation and statistical distributions of the placement over time and
they're
errors.
a really good company as an example of what you need to do to be successful, and it's partly the hardware, but it's like I have one of their new Pro 16s here, which is really a neat piece of equipment, and another example of how you can do so much with a lot fewer resources now. It had one small problem, and it's funny because it's got all these FPGAs and fancy pick and place PC boards and a really beautiful case, but the brown wire on channel 1 was broken. And, the very lowest tech part of it. But the thing that makes a difference is their response, because they were super responsive to that problem. I think they probably appreciated that I troubleshot the thing for them and figured out that it wasn't like a dead part of the FPGA, but it was just a wire. And
talking about I'm sorry.
I was just saying, but the difference between them and maybe some other companies is that they were super responsive to it and took care of me, and that just builds a lot of. I'll buy more stuff from them later, I'm sure.
Brand equity is the term you're searching for there. It's the douchey marketing term.
Just doing the right thing.
Yeah.
You talk about those, those little errors that creep in. Did you ever notice in your book that you wrote about getting started with Bluetooth Low Energy tools and techniques for low power networking, available now on Amazon for $34.01, at least to me, which is probably the hyped up price because they always screw me. But I in my copy, I was reading it, and at the very beginning in the intro, when they give you all the formats and everything that's going on in the book, they have two little icons in there. One looks like an icon of a lemur or something, and the other is an icon of a scorpion that's supposed to point out when dangerous things that might happen or things to watch out for. Then I go through the entire book, and every place where there's one of those icons put, it's not either one of those. It's a bird.
Oh yeah.
So I said, where's the scorpion? Where's the lemur? It's always a bird. What does the bird mean? Did he eat the scorpion?
Yeah, no, I didn't have anything to do with that.
The iconography is not your forte.
I did have a question that I haven't gotten around to asking you, but what were the mechanics like writing that book with four people and with O'Reilly as the publisher? What was that
how
like?
That got started was O'Reilly came to me and asked me if I'd write a book, but they wanted the book out by the time of their Solid conference. So they wanted this. It wasn't a long book, but they wanted it done in May, and they were talking to me in November. And I hate writing. so I found
confirmed engineers,
I found
folks.
3 other guys that are really good at writing and like to do that, and got them involved. And and one of the guys actually, Carl's, is involved in the Bluetooth Low Energy stack for
the standard?
For Nordic Semiconductor, and Kevin Town, they're all young guys with a lot of energy. So I did my little part, and then they did all the 6.
Oh, Kevin is that
Microbuilder?
I forget his name. Mike.
And he's also
on Twitter. That's right. Yeah.
The head engineer or something for Adafruit. And then Freak Labs, Akiva. There's a good group of people, and but it's all done. You do the book completely online, And so it's really easy to.
I mean, how online? It was just some package or something that you use, or is it like Google Documents?
They have their custom. They have their sort of custom packages, but it's really built around GitHub.
Uh-huh.
Yeah.
So you
it's
can
like a markup
use,
language, right?
Yeah.
Okay.
It's a markup language. So all those little birds and stuff come in later as part of their.
Well,
those are just tags.
That's neat.
Yeah.
I mean, because when I wrote books for like Prentice Hall, it was all type the book out and do your own figures, and then turn it over to them, and then they'd redo all the text, and then they'd redo all the figures, and you had to go back and reread it all again and reproofread it and recorrect it. And,
yeah. Well, we had an editor that kept us in line on the English language, but it was the neat thing was, so Kevin's in Paris and Carl's was in Barcelona, and Akiba was in Tokyo, and I was in Boise. I have to get a T-shirt that says Tokyo, Paris, Barcelona, and Boise.
or maybe going around the world with Bob.
Yeah, but it, because it was all online, it was pretty easy for us to all stay synchronized. And
yeah, it's nice that they have that O'Reilly has a system set up to do that.
No, it's an excellent system, and if people have ideas for writing a book, O'Reilly's was really good to work with, and I highly recommend. And you can just go propose a book to them, and possibly they would run with it.
The word on the street, Bob, is that with the royalties from this book, O'Reilly gave you a jewel-encrusted gold battleship.
Yeah, something like that. Actually, it's not a very lucrative thing. I kind of had to look at it as a marketing.
It's a promo thing.
Yeah.
Which is when me and Bob got to meet at Solid, so that was good.
And I also got to learn about how Bluetooth Low Energy works.
There you go. Yeah. Learn and write at the same time.
Yeah, that was the thing when I was a college instructor, and I had to teach a class. I'd say, well, I have to stay at least a chapter ahead of the students, and so I guess when Bob was writing the book, he said, well, I guess I just have to stay a chapter ahead of everybody else.
Just find smarter people than me to work with. Yeah. I also remember from teaching, like I taught electromagnetics for like 3 or 4 years, and boy, by the time you're done with that, answering all the questions that people can ask, you really get it down pretty cold compared to just being a student going through it. It's kind of like the difference between driving a car versus being a passenger in a car. I think.
Exactly.
You both get to take the same trip, but
one of you can actually remember how to get back. The other one can't.
Well, guys, thank you for being on the show. This has been another successful impedance matching episode, I think.
Thank you very much for having us, Chris. And I'd like to point out that I did not once mention my butt crack.
That's always a good thing.
Yeah, minus one for that one.
Blew it at the end.
Yes, but if people don't know the reference, of course, go back. There are great interviews with both Bob and Dave separately. Previously, Bob was the episode 144, and Dave was 181. We'll link both of those, of course, into the show notes. Definitely worth a listen. Lots of good stuff in there too.
Well, thank you.
Thank you, guys.
We'll have you back on again, I'm sure, sometime soon.
Okay.
If there's not the cantankerous, grumpy old guy vibe here, we're doing something wrong. So.
Okay, I gotta go now. I gotta go pass a stone.
That's right.
God.
Well, good luck with all that.
Okay.
We'll talk to you guys soon.
Thanks, guys.
Okay. Bye-bye.